Class in 5 minutes. Class in 5 minutes. Giving YouTube time. We're giving YouTube some time, y'all. Going live in a few minutes. Class in 2 minutes, guys. We're having a show in 2 minutes. Class in 2 minutes, guys. We're having a show in 2 minutes. Just giving YouTube some time. Okay. How we doing? How we doing? How we doing? How we doing? All right. And ladies and gentlemen, boys and girls, we are live. Welcome, ladies and gentlemen, to another episode of Call-in hour. No, it's not call-in hour. It's not shop talk. Tonight is just class, y'all. Welcome, ladies and gentlemen, to another episode of YouTube's premier off-the-clock appliance repair talk for off-the-clock appliance repair techs. I'm your host with the most, brother B. And tonight we got a class on defrost theory. Okay, let me elaborate on what's going on tonight, ladies and gentlemen. As y'all know, I host classes on Saturday. We hold our virtual workshops. But for the last 2 classes that I taught in particular, I had computer problems, so I couldn't upload Saturday's classes. So we're going to have it tonight. Ladies and gentlemen, if you already know Defrost theory, tonight's class may not be for you, but I figured since I gotta re-upload a video on Defrost theory for the TMM academic guys, I figure I'll kill two birds with one stone, do it in tonight's class, and give tonight a live audience. So we're gonna be taking questions about anything that you have, but in the most part tonight, we're gonna be talking about refrigerator defrost theory. Alright? Let's get into some news real quick. Let's talk about some stuff. I made notes tonight. Tonight's going to be a good class. If you don't have refrigerator training, or you're not really good at refrigerators, or you're not really good at troubleshooting defrost theories, guess what? Tonight you got to pass. You ain't got to go to tmmacademics.com to get this kind of training. Tonight we're going to upload it for free. But if you want training like this in depth where you can interact with a group of people, be part of our tech-to-tech walkie-talkie application, please go over to tmmacademics.com. Also, want to give a special shout out to last week's winner, Juan. I don't want to mispronounce the last name. But Brother Juan, we just sent out your shirt yesterday, so you should be getting that in the mail for first place. Want to give him a special shout out. You know what I'm saying? He was the winner of last week's Jeopardy challenge. I hope y'all enjoyed that. Next class is gonna be Hangman. Mac. Somewhere over there. I'm in the middle of a class. We're gonna be hosting a Hangman again at a later time. Tonight's class, y'all, tonight's show is about defrost systems. We're gonna be going over testing thermistors, timers, bimetals, heater elements, and talk briefly about how all of that works with boards, alright? But before we get into tonight's class, let's go over news briefly. If you're slow, you need work, if your phone ain't ringing, please go visit our sponsor, AMJ Marketing. Tell them Brother B sent you. The link will be below when this video is uploaded. Cash calls, same day, in and out. Like to give a special shout out to our other sponsor, workiz. Those people are really going to revolutionize the game. Get with them now. They have so much stuff with their platform. Your truck, there's inventory, 1-800 number, route management, customer database, a chat box for your customers to call on the phone and set up appointments automatically done through the app. More to follow with workiz, but they're something else. Be on the lookout for them. Description will be below. Also, again, shout out to our last week's contestant winner for our Jeopardy game, Brother Juan. Your merch went out today. I'm sorry I didn't have time to ship it. I finally went to the post office today and I put it in the mail, so you should be getting that. I'd like to take our second place winner, A Kitty, and our third place winner, Kix Lopez, for last week's Jeopardy. Alright? And then lastly, ladies and gentlemen, just want to inform y'all that I'm going to be on vacation for the next month. There won't be no more Friday night call-in hours or any more Friday nights for at least a month, maybe 2. As y'all know, I've been doing this a long time, and me and my business partner Rick, we really trying to get into the a little storefront, a little training headquarters / facility center. So I'm putting all my attention into that. And I'm trying to do the next time we do a live event like this, we're doing it in our shop. If you've been following me for a long time, y'all know last year around this time, I took a little time off. And then when I came back strong and bigger than ever. Well, this time I'm going to take some time off. But when I come back again, live that is, we'll still drop tech talks. We'll still have shop talks. We'll still have little videos in between. But live, like this, the next time we do it, we trying to do it in the studio. So y'all may not see me live on a Friday night for a month or 2, but there's some other channels out there y'all could go get information from, and they should be able to hold y'all down until I come back. But I just need a break, y'all, and I want to put my energy and my effort into my facility. All right, so I'm gonna be gone for a little while, but like I said, there's other channels. Go check them out for good appliance repair content. With all that said, let's read some quick comments. Again, forgive my setup. You know, I look good with the live by the gun, die by the gun, but I'm in some gym shorts. I just got out of work, got out of the shower, and here I am in YouTube. So forgive my appearance. All right, let's see what we got here. All right. Flanders Appliance. Damn, this is the first time I've seen this gentleman tap in. What's up, Flanders? Thanks for tapping in. You wouldn't be Dean Flanders, would you? The Blue Book gentleman, would you? If you are, thanks for tapping in. And if you're not, thanks for tapping in too. Greg B. What up, brother B? What's good? What's good, Greg? How you? Alright. What this says here. Magic 7800. Is it possible for a three-way valve to be bleeding refrigerant to the coil when it is not asking for a cool and cause a defrost issue? Magic, I'm not sure of what you mean, but since I got a whiteboard, we could do some drawing. I'll show you briefly, Brother Magic, about that three-way valve. So that three-way valve has three destinations, right? You have the freezer, evap. We have the fresh food evap. We'll just go FF, evap. And basically what this three-way valve does is it has three positions. Either it's going to be given freon, it's going to be supplying freon to this compartment. That's position 1, or it's going to be in this compartment, fresh food, position 2, or it's going to be in position 3, which is access to both. All right, I hope that makes sense. All right, let's see what else we got. Who else we got here? Flanders, is it possible for a three-way valve to fail in that way? I don't really see three-way valves fail, guys, to be honest with you. The way that I check them is I plug it in, I put my hand on it, I count 12 seconds, and then I disconnect the refrigerator. More than likely, that'll put your three-way valve in the home position. Any other questions? We'll save that for, well, go ahead. Tonight's for y'all, so I'm here to help y'all. All right, any questions, keep bringing them. Okay, on the fresh food section, the coil does not have a defrost heater, and I already changed the thermistors on it. But Magic, I don't know what's your problem. Are you not cooling, or you having a defrost? I don't know what you're going through, brother. Put it in the comments. All right, Whirlpool. Okay, I'm assuming he's talking about for Flanders. He's talking about a three-way on a Whirlpool. Flanders, I don't see them go bad, man. I hate to inform y'all. If a three-way went bad, how you would kind of know is if more than likely you getting cooling in one section and not the other. But there's a tech sheet out there that it'll show you how to test resistance on that three-way valve coil pack. Because on the top of the three-way valve is a coil pack that you can check continuity between certain pins. I'll do a video about that another day, but tonight I want to get into defrost. If any more questions, I'll do another video about that, alright? Alright. Charged up services. What's good? What's good, charged up? Kirch, 12 seconds on all three-way valves. I mean, you know, I like to unplug it, you know, when I get there, wait a few seconds, then plug it back in, right? And when, as soon as I plug it back in, I got my cover where the evaporator compressor is. I remove that cover, and when I plug it in, I go right to the, you know, to the refrigerator, and I put my hand actually on the three-way valve. I feel it, and you'll hear it moving like brrr, brrr, that's the sound it'll make. But like after 10-12 seconds, I'll unplug it, and then that's when I'll know I have it in the three-way position. And on Whirlpools, at the user interface, I think you gotta hold like switch 5 and 6 for 3 seconds, and then I think step 4 or 5. I need the schematic. I'm shooting off the hip, but it will allow you to put the three-way valve in what they call home position. This gives you access to both. But again, can we talk about defrost, not three-way valves? Love, peace, and harmony. All right. Who else we got in here? Alright. Want to give a special shout out to my brother Trinity. What's good, Trinity? I love the logo, man. That's my guy right there. You know what I'm saying? Kurtz. What's good, Kurtz? Okay, John L. Brother B, how do we check for refrigerator leaks? Man, y'all not. I thought I was gonna do defrost. Y'all want sealed systems? All right. Well, let's talk a little bit about that. All right. John L. Let me answer your question. How I check sealed system for leaks? There's actually a few ways you could do it. The first is as always, y'all, thank y'all for being here tonight. Love, peace, and harmony. I hope y'all enjoying yourself. You know what I'm saying? I hope y'all had a good, productive week. But tonight we're going to get deep into theory and we're going to become, A1 professionals. Again, live by the gun, die by the gun. Please support our merch. All right. So, Brother John L., this is how I check my leaks on my seal system. Oftentimes, your compressor, when you arrive, is going to have, let's use a different color. Blue. Alright, we'll just put the word comp as compressor. More than likely, it's going to have 1, 2, and 3. Alright, it's going to have 3. Let me grab a compressor. Alright, so here's a compressor, right? Let me see how I look on here. Alright, beautiful. As y'all see here, the thicker of the two, this one here, this is your low side. This is your high side. This is your service port. Right here, you're gonna hook up an access valve, right? And then, this you're going to put to your condenser. This is going to come to your evaporator. Like, you're going to hook these two up, and then you're going to put an access valve in here, right? Now, once you put an access valve on there, which will be here, right? Here's the access valve. What you're going to do is you're going to take your blue hose off your manifold. Here's your manifold, right? Y'all know y'all got 2 gauges. Or this, the gauges. You're going to hook up the blue one to here. The yellow one, you're going to put it on your vacuum pump. And what you're going to do is turn on your vacuum pump and open up your gauge on the blue side, right? What's going to happen is you're going to see your gauge, it's going to want to be at 0, right? And once you begin to pull it in a vacuum, it's going to want to climb to -30, right? PSI, inches mercury. Well, when you have that manifold gauge open and you turn on the vacuum pump, like I said, it's going to be 0 and it's going to climb to -30. Once it's set or close to there after like 20-30 minutes, close it, close your vacuum pump and watch the needle. If the needle goes back to 0 or it's trying to edge its way back to 0, then you have a leak. If it remains in 30, you don't have a leak. That's one way. Another way is pressurize your system. Make sure you solder everything good, you check everything, and then put nitrogen in it. When you put nitrogen in it, rather than it go to -30, it's going to go to like 50 or 40 or however much PSI nitrogen you put in it. But what you want to look for is that it stays at whatever amount of nitrogen or freon you put in the system, that it maintains, on the low side gauge, wherever you see that needle, after like 5-10 minutes, that it stays there. If you see it deviate or trying to get back to 0, that means it's leaking out. If you have it in a vacuum and it crawls back to 0, that means that it's leaking out. That's 2 quick ways to help you. All right? I hope that helped. Damn, y'all can't see that board. Oh, y'all can see it a little bit. All right. Okay. who we got here? Magic. It keeps icing over the fan, then freezes over and cooling the whole coil. Just freezes over. Did you check your board? If you check your thermistors, another good one. Magic, you making me work tonight, Magic. I came to talk about defrost, and you got me talking about, well, I'll show you. So, look, here's what you got. The thermistor, wire harness, board. That's it. That's your circuit. Board, wires, thermistor. Let me use a different color. This color sucks. Let me try purple. Thermistor. Alright? Oh yeah, that's much better. Alright, so look. Here's your thermistor. Right? I got one today for y'all. What'll happen is this will go on your evaporator coil. It'll sit on your evaporator coil. And what'll happen is this will send information back to the board. Right? But this is it. This is your theory. Then you have a wiring harness that comes from this board to this thermistor. But that's inside of the refrigerator. You can't see that or access that. So what you want to do is, from the board, you want to find the connector that goes to this. And what you want to do is you want to measure resistance at that board. And it will give you the excuse me, I'm in the class. It will give you the resistance of this thermistor. So you can check the thermistor itself by disconnecting it and putting your voltmeter in here. Like so. Here's your voltmeter. What you would do is you will put them into here. Do not use continuity because it won't read. It'll give you OL. What you want to do is use ohms, and this thermistor is giving me a this thermistor. Bear with me, y'all. Always check your voltmeter leads to make sure that you're good. All right, cool. Cool. And then as y'all see, it's 11.41. Hopefully y'all can see that. Yeah, y'all can see that. 11.41 kilo ohms. And what am I doing? I got my voltmeter inside of these leads, all right? But you could do that same test from the board at the back of the refrigerator. This is the back of the refrigerator. More than likely, the thermistor Molex is in one of these two. Go to your schematic, but disconnect it and put your voltmeter at the wire harness here, and that'll tell you your thermistor. I hope I did an okay job of explaining that. I'll elaborate more on that, but I want to get into defrost tonight. Okay, Kirks, talk about thermistors from the board. I kind of touched on it. We'll do that at a later date. All right. Again, please support the merch. All right. Okay, I think we answered everything as far as that. Tonight, guys, I want to talk about defrost. Defrost theory, all right? Defrost theory. This is a money maker job. Y'all see it all the time. I'm sure y'all get on jobs. The first thing y'all do is y'all get to a refrigerator. They say it's cooling in one compartment, and it's not cooling in the other. You get to your freezer, check with your infrared gun. You know, we live by the gun text. So we check, we got good temperature on one side, but we don't got it on the other. What you want to do is look at that evaporator coil in the freezer compartment. And when you see it all snowed up and full of snow and all that, then you have a defrost failure. At that point, couple things, all right? So now that we have the defrost failure, let's talk about a little bit about defrost and all that and exactly what it is. All right? So, as y'all know, y'all turn on the refrigerator. As y'all turn on the refrigerator, that compressor begins to circulate freon throughout the unit. We all agree to that. But in the evaporator compartment, which is located inside of the freezer, sometimes in the fridge is if it's dual evap, but for tonight, single evap. In the freezer, where your evaporator coils are, what happens is as Freon begins to circulate and you open the door and all the cold air, it wants to go to the coldest portion of the freezer. Well, that's them coils. And every time you open up the door and as Freon passes, they begin to snow up and they begin to become full of snow and frost. Well, refrigerators have to turn off, if you will, allow all of that to melt off and then turn back on. That right there in layman's terms is called your defrost cycle. And tonight we're going to talk a little bit about that. And I'd like to shout out the TMM Academic guys because I gave them this video, but since it didn't upload, I'm going to give it to the world tonight. But shout out to the TMM Academic brothers that be there. Alright? Every Saturday, y'all faithful. Y'all the real MVPs. Okay. Let's talk about defrost theory. Okay, so as frost accumulates on the evaporator coil, the airflow through the evap coil will begin to decrease and cooling effect will also decrease. As y'all know, where those coils are, down here, y'all know they put a little fan up there, right? And what happens is that fan blows air into your fresh food compartment. But when all these coils are iced up, it can't do that. You know what I'm saying? So cooling decreases. Alright? What happened is that back in the days, many people, before they had like defrost cycles and all that, people used to take like ice picks and knives and stuff, and they would go to the coils and they would try to like scrape the ice off. But what was happening was they were puncturing the evaporator coils. So you have freon leaks and you have people destroying their refrigerators. Well, after some time, what manufacturers did was manufacturers got hip and said it's better that we do the defrost cycle automatically. So in comes your defrost. In comes your defrost theory, and in comes like, you know, everything associated with that, which we're going to discuss tonight. Alright? So, there's a few types of defrost systems that I like to talk about tonight. One being Ward, one being ADC, which is an acronym for adaptive. This is Whirlpool technology. Adaptive, Mac. Come on, man. Adaptive, defrost. 1 second, guys. Come on, Mac. Let's go. Come on. You're making too much noise, man. I'm in the middle of the YouTube. You over here destroying the phone. You can do that outside. Come on. There you go. Apologies, guys. As y'all know, I got a dog, Mac, the real MVP, but sometimes he likes to crash the party. Alright, so we got adaptive defrost control. That's a Whirlpool style, a Whirlpool-esque defrost system. We'll talk briefly about that. There's timer defrost. That's this guy over here. We're going to talk about a timer tonight. Something called hot gas. You see that really on like ice makers and stuff, under the counter ice makers. You don't really see that too tough, but we'll touch briefly on it. And then the final one is cumulative run. Alright, so we got 1, 2, 3, 4, 5 different styles of defrost technology that you may see in refrigerators. I'm not saying this is definitive, but these is the most popular ones. You know what I'm saying? Board, ADC, timer, hot gas, and cumulative run. Alright, we talk a little bit about all of them. Who we got in the chat? Let's read some chats. Again, y'all, thank y'all for rocking with me. Y'all gonna enjoy tonight's show. Let's see who we got here. Alright. Okay. 0.510. Should the thermostat either let 120V or 0V go to the heater? We're going to talk about that. Trinity, Laurent, what's good, Laurent? B, do you check a defrost heater for continuity or ohms? I got props. We're gonna do that a little bit later on. But for tonight, let's continue with the theory. Let's have that tool on our tool belt. We have defrost theory in the bag right here. So can no customer try to trick us. We know what we're supposed to have, and we know, sound understanding of the appliance. All right, so let's continue to stick to defrost theory for tonight. All right, let's talk about the most common. Nowadays, refrigerators go into defrost due to the board. The board nowadays is what you will see in most current refrigerators. You won't see timers. You won't see ADC boards. You won't see hot gas. You won't see none of that. What you'll see is a board. You'll see this right here. And on this board will provide the defrost cycle. This will put the refrigerator into the defrost cycle, this computer board. But you may ask, how does it accomplish that? Well, this is an LG. They call this like a controller, if you will, but it's basically a thermistor. This orange one here, how do I look here? Let me see. I gotta look at this to see what y'all seeing. This orange one here. Let me see. Oh yeah, this is it. This is your thermistor. This goes on the evaporator coil. All right. That's one example. Here's another thermistor. All right. So what happens with these thermistors is, oh, I shouldn't have erased that. Fuck. Whatever. What happens with those thermistors is they use a chart, and I said this in one of my other videos. Please go check it out. There's Thermistor Charts, and what'll happen is you'll see a chart like this. You'll see a chart that'll say like this: temp, ohms, and volts. Now this is hypothetical. This ain't accurate. This is me shooting from the hip. Refer to your tech sheet. Every tech sheet is different. So you'll see something like 10 degrees Fahrenheit, 20 degrees Fahrenheit, 30 degrees Fahrenheit. And what'll happen is it'll tell you the ohms. 10,000, 15,000, 20,000. So, and then it'll give you the output voltage at the board, which will be something like 4 to 7 VDC, direct current, DC, not AC, alternating, DC. And that'll be something like, I don't know, this is hypothetical, 5 and 6.1. All right. So now we at our fridge. We go to the board, right? We discover we have a defrost failure. We say, okay, we got a defrost failure. We go to our tech sheet. Our tech sheet gives us our thermistor values, and at the board we check our thermistors. We go to the connection of the thermistor. We disconnect it from the board. We unplug the refrigerator. Well, do that first. Unplug the refrigerator, then disconnect the thermistor plug and test the plug. Don't test the board, test the plug. And when you test the plug will tell you, the ohms of that resistor. Let's say you get something like between 10 and 15, 13,000. Well, you should have a reading of somewhere about 15 degrees Fahrenheit. How do we verify that? We take an infrared gun and we point at the thermistor. We live and die by the gun. So now that we know our resistance at the board, now that we know our temperature based off of infrared gun or thermometer or KY thermocouple, use some instrument. But once you verify your temperature with your ohms, then you want to plug the plug back to the refrigerator. Then you want to plug the refrigerator in. Wait a few minutes and check output voltage with the plug connected to the board. Put your voltmeter where the thermistor harness is, and you should get the output voltage VDC, volts direct current. So make sure you take your voltmeter and you take it out of the AC, alternating current setting, and you put it in the DC, direct current setting. And that will give you your values of your output voltage at the board. So that will tell us if our board is giving us good output voltage. That will tell us if our harness is intact, because if we're reading ohms, then we know that our harness is good enough to read the thermistor. Now, if we don't get ohms, we may want to go to the thermistor itself and inspect the wiring harness and make sure that it's good. And we're also getting our temperature, and we're doing that via some instrument. We're not using our hands. We're not using how we feel. We're professionals. We use instruments to gather temperatures. All right. So there y'all have it as far as like how boards are able to distinguish and determine when to put refrigerators into defrost mode. They use thermistors to read the temperature to send the resistance back to the board. And that resistance will tell the board when it needs to be in defrost and when not. That's why if you look at them, some of these thermistors are even called defrost thermistors. Alright? Alright. Let's see what we got here. Alright. Let's read some. Oh! L Lemon, I guess. What's good, brother? What is the common use for DC in an appliance? When should you do a DC voltage check? Well, on your thermistors, like we said earlier, they're DC. On most of your fans, let me grab an evaporator fan. Hold on. Here's an evaporator fan. Where does it say AC? Okay. Let me see if I could get this zoomed in really good. Hold on, y'all. But if you look at... Man, I can't show you, brother. If you look at the reading on here, it'll tell you VAC or VDC. If you see 120V, you know that's AC. If you see 5 to 12, you know it's DC. Alright? So that takes care of that. Alright? Hopefully that guy got that. What's good, L. Lennon? Thanks for tapping in. Oh, my brother's in here. Richard Zilka. Love, peace, and happiness, big bro. That's my guy right there. He's the real MVP. I want to thank y'all for giving him love, on his birthday. Thank everybody who tapped in. Thank you for everybody that watches his videos. As y'all know, I'll be in the field putting in work. He's the behind the scenes, updating the website, uploading the videos, and giving us the tech talk and handling all that. So without him, this channel would be nothing. I love you, Rick. Again, that's my guy. Thanks for tapping in. All right. Let's see what else we got here. Alright. Trinity. Oh, what's good, Trinity? Alright, Kirks. DC lines are generally the thinnest wire. I have different leads. That's correct. Kirks. DC lines are generally the thinnest. I don't have a wiring harness with me close, but DC wires, alternating current, are typically more thicker, while your DC are typically more thin. Good observation, and I concur. All right. Richard Zilka. DC voltage works well with variable speed fan motors and thermistors. There's your answer. Okay. Alex. Help. Still at 95% recall rate. Average 5 calls per day. Whoa. That means if you do 10 jobs, you go back on 9 of them. Brother Alex, man, go to TMM Academics, man. You need to sign up. You need to go on our Voxer and you need help, bro. And I don't mean that like as a sales pitch, but 95% recall is completely backwards, man. You should be at 0.5% recall and 95% success rate. But we all started that way, and at least you recognize it, that you need help, and you tapped into the right authority. At least you ran into me rather than somebody else. We'll take care of you. Come on over. Tap into tmmacademics.com. All right? Buckball. Man B, when the hell you start working on sealed systems? Man B, call 72. You must not tune in. I've been doing this for a long time now. But thanks for tuning in, and I love you, and I hope to see you again. Just came across this stream looking for an issue I had with an LG. What's the issue? Put it, we'll talk about it. Actually, LG is my favorite. Alex, I'm throwing all, you don't need to throw Samsung's out the window no more, Alex. More than likely, Samsung's is more than likely a drain pump. That's what I always change with them. I noticed that's a big failure. All right? But that's not definitive. Refer to tech sheet, put the unit in diagnostic mode, retrieve error, go to the circuit of interest. That's the proper way. All right. Creative Connection. Thank you for wishing my guy happy birthday. What up, Creative? What's good with you? Richard Zilker, we are getting an LG refrigerator tomorrow and going to create a special on sealed system and actual do a compressor change and software update. Rick, you beat me to the punch. That was a secret. But yes, since the cat is out of the bag, yes, we're gonna get an LG and we actually gonna show y'all how to do that and actually do a sealed system compressor replacement, bundle it all up, and we're gonna get that out to the public. I didn't want to announce it yet, but that's definitely happening very soon. All right. All right. Yo, Rich in here. Rich taught me Miami Lakes 25 years ago. Damn, that guy's an OG. Dawn Everett. What up, Dawn? All right. Okay. Solid Steps. What's good, Miss Rochelle? Miss Ward, how you? All right. All right. So we read all the comments now. All right. So now we spoke about your board. All right. We said that a board uses the thermistor to relay information back to it to let it know when and when not to enter into defrost mode, right? Now, let's talk about a different technology. Different setup. Again, please hit the like. Please hit the subscribe and please hit the share, alright? I'm gonna be going for a little while, y'all. Going on vacation for a little while. Alright. So the next type of defrost technology I want to talk about is your standard timer. I love this guy. Okay, so here's your timer. This is your defrost timer. Alright. If you see this will generally, a subcode will generally work anytime you see one of these. Alright. The way these guys work, they're pretty standard. This is not definitive, but this is general. Not definitive, but general. Most of these guys, they work on either 8 or 12-hour run and then a 30-minute defrost. Alright? Now that's indefinitely. So run for 8, defrost for 30. Run for 8, defrost for 30. And it does that indefinitely. Now, if you get a defrost failure, and you do see one of these, if you ever want to check, I want to show you guys a trick here. Listen very carefully. You're going to listen to something. Listen. You want to take a flathead and put it in this little groove here, and you want to turn it. Now, as you turn it, you want to listen. Listen to this. All that click, 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 click is cooling. But when you hear a real big click, that's when it's going to go into defrost. Pay attention. There you go. Y'all heard that big click? Now that was 8 hours. That was 8 hours of click, 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 click. You know, we did it in 10 seconds, but that's 8 hours. Now the 30-minute defrost cycle, you ain't gonna do all that clicking. It's a short twist of the knob before it clicks again. Listen. That's it. When you hear that secondary click, now she's back in cooling, and now another 8 hours. Defrost, back to cooling. Hope that answers it. All right. Okay, where we at now? This is such a great career, constantly learning something new. What up, Alex? Samsung's applying. I agree with you, creative. Buckball, he's in Atlanta. What up, Buckball? Okay, they are doing politicking, so I'm gonna let them do some politicking, and we'll get back to theory here. So again, the way that this guy works is, this is a simple schematic, okay? This isn't definitive or nothing. But what happened with this guy is, I'm gonna do my best to draw here, all right? Y'all bear with me. So what happened is, you'll get 120 come in. It'll go right to the timer. The timer will have 4 contacts. Number 2, number 1, number 3, number 4. And then you'll see some sort of a coil between 1 and 3, and then you're gonna see a switch, right? So when it's on position 4, it's in the cooling. It'll go to your thermostat. Then it'll go to your overload. Then it'll go to your cap, which is aka capacitor, followed by compressor. All right. So, and your fans. It'll definitely do fans. Both evap and condenser. All right, so let's think about it. When it's in that number 4 contact, and if you look here, it'll even show you on the numbers. I hope it shows it. I hope y'all can see that. This pin right here, number 4. I just want to make sure y'all can see that. Hold on. Nah, it's not clear enough. But if you look though on the timer, there's numbers. Well, from 1 to 4, it's in the cooling. What it's actuating is your compressor. It's going through your thermostat, through your overload, capacitor, compressor. It's in your fans. Like everything right now is cooling. Fans and compressor. cooling. But when it gets out of that and it goes up to here, to number 2, that will take you now to like your your bimetal and your defrost heater. So that'll take you to your bimetal. That's an actual schematic symbol. And then heater. Okay. So heater, and then we'll say bimetal. That's the schematic for a symbol for a bimetal. Basically, it's and I'll show you one of those too. I got one of those here too. They open and close based off of temperature, but we'll talk more about that. So again, your timer is this guy here. If it's on number 4, it's doing the cooling. When it goes to switch 2, now it's in the bimetal and it's in the heater, back to neutral. I hope I'm making sense to y'all. But basically, that's what the timer does. The timer will either have it in the cooling, compressor fans on, when it's on 4, position 4, or when it's in position 2, it will do the heating, the defrost, which first goes through the bimetal, then goes through the heater. And we'll talk about that bimetal here and how it opens and closes and it uses temperature to do all of that. All right? So again, that's your timer. Oftentimes when this fails, go ahead and replace this and the bimetal. You can get both for under $10. Job done. No recall. As long as your wire harness is good and your components is good. So when you see this, always change this and change the bimetal. You probably won't get a recall. And check your heater element for continuity. If your heater element tests good for continuity, you should be good with changing this in your bimetal. Alright? So that's the second style of technology. Defrost timer. Alright? Let's read some more comments here. Okay. Okay, when y'all do the LG seal system video, can you take replacing the evaporator coils? Bro, we're going to do the condenser coils and show you how to pressurize, test that, and check that for leaks. We're going to show you how to do the evaporator coils, pressurize that, and test that for leaks. We're going to show you how to do your capillaries. We're going to show you how to do dual evap, single evap. When you know us to give subpar information there. What's this guy's name? What's his name? Creative Connection. We're going to take care of you. Don't you worry. All right? Oh, no, I'm sorry. Charged up. Charged up. Forgive me, Creative. Charged up. When y'all know us to do nonsense, we're going to take care of you and give y'all a good video. Charged up. All right? Alex M, can't find the tech sheet on LG top load washers. I will refer you to go to appliantology.com. The samurai's over there, and that guy got everything. All right. Who else we got? Richard Zilka, we are writing the script now. Rick, you throwing all the info out, man. Don't tell them nothing. Keep it as a surprise. All right, just know that we got some good videos on the way. All right. Anthony Gents. What's up, Anthony? John Doe, new subscriber. Thank you, John Doe, for tapping in. John L, can you explain ADF system? We're going to discuss ADC, Adaptive Defrost Control System. I'm not familiar with ADF. Daryl Harris, how do you know when the cap is bad timer? I think what you're asking is how do you know if the capacitor is bad? You would put your voltmeter in farads and you would do that, but we'll talk about that at a later date. All right. Daryl Harris, we're gonna take care of you, but let's stay in the light of the thing. But again, if you want to check to answer your question briefly, to check capacitors, put your voltmeter in farads. this guy over here. Let me make sure y'all see that. I gotta look at my screen to make sure I could. I'm giving you the best I got. I can't show you, man. It's that little. It looks like this, though, brother. I'll draw you the symbol. Where the hell is my marker? It looks like this, brother. On your voltmeter, alright? It would look something like that, alright? Alright. Okay, so let's talk briefly, guys, about what we've got so far, alright? It's 11:15 and y'all out here with me, man. Shout out to all 29 people who tapped in, man. Love, peace, and harmony. Where would I be without y'all? You guys are the real MVP. Alright, so check this out. We talked a little bit about defrost. We said to look for snow on the coils. We explained why that happens. We explained how manufacturers try to make that problem go away. We made mention of how boards work, and we made mention of how defrost timers work. Another thing that I want to talk about, and I believe somebody made mention of it, it was what's called the ADC, the Adaptive Defrost Control Board. Whirlpool came out with that. I don't really see it too much, but basically, let me read my notes here. Yeah, the way that so a board, we said that it uses thermistors, right? The thermistors send resistance based off the temperature on the coil back to the board. The board decides when it wants to go into defrost. We said a timer's nothing like that. It's mechanical and it's standard. 8 hours on, 30 minutes off, 8 hours on, 30 minutes off, 8 hours on, 30 minutes off, indefinitely. We spoke about those two systems, but I'd like to talk about a third system, which is, I believe that brother had that question. It's called the ADC board, Adaptive Defrost Control Board. You don't really see it no more, but they're still out there, and I run into them every now and then. But basically, the way that board doesn't use thermistor or anything like that. The way that board operates is that board uses how many times the door's open. It counts that, you know. It also counts how long was the refrigerator in its last defrost. Like if it was 2 hours ago, it probably won't put it in a defrost again, you know. So it factors that. Another purpose of the ADC board was because of the high efficiency, manufacturers didn't want that mechanical 8 hours on, 30 minutes off, because maybe it didn't need 8 hours on. Maybe it only needed 4 or 5, and it achieved its desired temperature that you selected on the cold control, aka thermostat. So what they said was, well, why are we running the compressor for 8 hours and turning it off for 30? Maybe it only got to run for a few. In comes the ADC board. So again, it uses an algorithm of door openings. Last time it went into the defrost, it's using high efficiency. It's using an algorithm that's not so cut and dry like the timer, which is 8 hours and 30 minutes. All right. So the ADC is a little bit more flexible, and it uses various input data to achieve its desired defrost results. All right. I hope that makes sense. That's our third. The fourth style that I want to talk about is something called your hot gas defrost. All right, this is old school. I've been doing appliance repair probably 8-9 years, and I've never seen this in my life. I see this on under the counter ice machines, and basically what the hot gas is, as y'all know, and I don't want to complicate this because you're never going to see it, and this has to do a lot with seal system. So to put this as simple as I can make it, what this system does is it makes your evaporator, in theory, your high side. So that hot vapor it will put it at the evaporator. And then your low side, it will go to the condenser. And the reason why it's in your evaporator, the high side, that warm vapor and all that, is to melt, the frost off of the coils. So they use that hot gas system. I'm not even going to try to explain that to you because you're never going to see it and I'm wasting my time. But just know that that's one of those old things that are out there. I've never seen one though. Just like our last style, which is called cumulative run, okay? Cumulative run defrost systems depend a lot, and again, you're not going to see this doesn't exist anymore, but it used to be a thing, so we're going to talk about it, but talk about it briefly. Your cumulative run basically depends on your compressor runtime. So as long as the compressor stays on, the cumulative run style defrost system, it uses your compressor runtime as an indicator of when to put the refrigerator in and out of defrost. Again, cumulative run style and hot gas defrost, you're never going to see those. But you will see timers, you will see ADCs, and more than likely you're going to run into your newer technology, which is your board and your thermistors. And more than likely that technology is going to be around more than anything. So I advise you strongly, learn your thermistors. Go back to my video and watch that thermistor training. Rick and I are also going to do a video on board repair and stuff where we show you how to actually troubleshoot from the board. But, me and him got to get together for that so he can hold the camera while I do it or vice versa. Again, hit the like button for my brother Rick, all right? He's the real MVP. And y'all are too for being tuned in and on a Friday night trying to increase y'all knowledge on appliance repair. The more you know, the more you worth, all right? All right, so let's move in now to our final. Portion here, where we're gonna actually have some components, and we're gonna go through the testing of those components. All right, let's read some comments. John Doe, you got a YouTube channel, Richard Zilka? Yeah, TMM Appliance Network. Thanks for tapping in, John Doe. Paul Zener, wow, hot gas defrost goes back to the 70s, the old Kelvinators. There y'all have it, ladies and gentlemen. I was born in 81. I told y'all, I never seen that, but if it's out there, at least you guys have the knowledge now to at least identify it. And that's what gives you your worth. When you go into the customer's home and you start telling them, oh yeah, there's different defrost styles. Oh, that old one, oh yeah, that's a hot gas. And then you have the cumulative run. Oh, that's a timer. Oh, your newer ones, oh, this is a board. It uses the thermistor. When you know this stuff off the top of your head, as you calling the customer and as you giving your estimates, they can tell if you know what you're talking about. Because y'all could check this, what I'm saying, and see if I'm full of crap or not. And y'all see that I'm not. Same thing the customers could do. So when you learn your theory, it helps you as a technician. And it helps with your pricing and all that. Because when I price, I know what I'm doing. So you're going to want to do the repair. And that's why it's important to understand your theory. All right. So now is a fun part. Let's talk a little bit about how to test these components. All right. Okay. This guy here, this is a heater element. Okay? Heater element. Very simple component. These normally are operated off of 120 volts AC. How you want to check these? You like to put your voltmeter on ohms. And I got a trick question. I got a pop quiz question here. And I'll take a break. And this question goes out to anybody out there. Anybody that's watching this. Can anybody tell me the difference between continuity and resistance? I'll leave that as a trick question. Put it in the comment section. And while y'all doing that, I'm gonna continue to talk about this heater element. So basically, you want to take your voltmeter and you want to put it on ohms, not continuity, ohms. All right. Once you got it on ohms, again, check your voltmeter to make sure that your voltmeter is good. You should hear a, but we don't want that. That's continuity. We want ohms. So what we're gonna do is take it out of continuity and put it in ohms, and now we're gonna measure the resistance of this heater element and see if it's open or closed. Open or closed. Let's see what we got here. This voltmeter, this heater element has a ohms of 57.4. How did I arrive to that? Let me put the light. How did I arrive to that? I put my leads inside of this Molex, all right? So when I get resistance, I know that I have a good element, all right? Let's see if anybody answered my challenge. Nobody answered my challenge? Don't nobody know the difference between continuity and ohms? Come on, somebody knows it. All right, let's talk about another thing. Bimetal. This is a bimetal, Defrost bimetal. Somebody had a question about this bimetal. The way that this bimetal works is, consider it a safety mechanism. Here's your voltage source, VS. We'll say voltage source. That could be a timer, that could be a board, that could be Lord knows what. We don't care in this particular case. We just know that this element is getting 120 VAC. We know that that element is getting 120 VAC. So now, the way that the bimetal works is, if something happens here, let's say that this messes up and it continues to send 120 volts to that heater element, and 120 volts to that heater element, and 120 volts to that heater element, what will happen to that refrigerator? More than likely it will burn down, right? The interiors will melt, it will burn, you get, it would be all messed up. So what the manufacturer did was to safeguard that from happening, because anything could happen. What they did was they put the Defrost bimetal into the circuit. So now, what you would have is, we'll say VS, voltage source. We don't know what it is, a board, a timer, whatever. That right now is irrelevant. But what they do is, they put the bimetal, we'll put BM for bimetal, and then we'll put element. That's your circuit. That's your circuit. So what happens is, this bimetal is considered like contacts, right? So from voltage source to element. What happens is, right now it's open. It's open when the temperatures are, let's say, because there's an actual chart for this, and I don't want to misspeak. There's an actual chart, and I want to give you guys this. So I don't mess up. But there's an actual chart and part numbers of your bimetals. Bear with me, guys. Okay. I'm going to give you guys, hopefully this works. Okay. So as y'all see, here's y'all. My thumb is on it. Here's the hold on, guys. I'm trying to give you. Can you see that? Oh man, I can't. I can't give it to you. It's not showing good. All right. So basically, part number L, and you can Google this as you're watching this. Part number L45. This thermostat will open at 45 degrees, and it will close at 25 degrees. L50, 50, 30. L55, so on. 35. Alright, so basically what they're saying is that when the bimetal opens, right now, this circuit is what we're concerned with. This circuit here. No, let me not delete that. Voltage source, thermostat is open at 45 degrees. Compressor kicks on, evaporator coils get cold. Now it gets cool. It's definitely going to get below 25. So what'll happen is this bimetal will actually complete the circuit, and now from the voltage source, it will send 120 volts to the element. As the element begins to get cherry red and heat up, this guy here, which sits under the evaporator coils, the temperature will rise. Well, when the temperature of this bimetal rises to 45 degrees inside of the box, what'll happen is it'll open. So now your voltage source will attempt to send voltage to the element, but the bimetal is open at 45 degrees. So they put this bimetal as a safety mechanism to prevent the heater element from staying energized and burning up the refrigerator. I hope that makes sense. Okay. I put a test, a check here. Let's see who answered it correctly. Okay. George V. Rod. What's good, George? Continuity is checked for a closed circuit. Resistance is checked. The specific ohms of resistance a component has. I don't know. That sounds to me like the most accurate answer. Let me read the rest. Black 12212. Continuity and ohms are the same thing. Incorrect, but close. Thanks for tapping in, Black. You always watch, man. I hope to meet you one day. Come check me in ASTI in San Antonio. We'll have something to drink, man, on me. It's good seeing you, brother. You always tap in. Thank you for that. Let's see who else we got. Okay, ohms is resistance. This is from John Doe. What up, John Doe? Ohms is resistance. Continuity is continuous connection. I'll take that as an answer as well. Creative connection. Continuity is the integrity of the path, and resistance is the difficulty and current traveling in the path. I'll take that. Yeah, complicated, but I'll take it. That's about right. Good job, creative. Richard Zilka, if you are checking continuity, does it matter if it's 0 or 100? Absolutely it matters, because some voltmeters, we'll talk about that later. Lieutenant Lawson, Richard don't matter. Nah, it matters, Lieutenant, and I'm going to explain to you why. Okay, quick fix. Ohms is the reading you get within the continuous path, and continuity is the beat to let you know it has a continuous path. Quick fix, that's partial truth. All right, let me explain to you guys the difference between the two. All right, and thank you for everybody contributing. And guys, this is to grow the channel. There's no right or wrong answers here. We all learning, and I appreciate y'all. Y'all have a lot of balls because y'all are putting comments that a lot of people ain't putting. So y'all are putting yourself front line and exposing yourself. And I'm never going to make you feel like, y'all don't know what y'all are saying or nothing. I appreciate the interaction, but I like to explain to y'all the difference between the two. And shout out to somebody I had this conversation with a long time ago. Unfortunately, that person and I don't know what happened, but I love you if you're watching this, homie, but you out of pocket. But with that said, I'd like to show y'all the meaning of continuity and resistance. So basically, what continuity is, consider continuity and resistance this. Let's imagine there's a point A and there's a point B. What continuity does is tell us that from A to B, we're in good shape. There's no electrical breaks. It's just telling me that from here to here, we're good. But the difference with ohms is, ohms tells you exactly the distance or the resistance in this case, from A to B, which would be something, this is hypothetically, it could be anywhere from 1 ohm to 1 mega ohms. You know what I'm saying? And that, again, that's just the resistance from point A to point B, the total amount. The only thing continuity tells you is that, like somebody said, it's no breaks, the integrity of the wire or the whatever the conductor is from A to B is in good shape, and it's not open or grounded or nothing. So that's the difference between continuity and ohms. Ohms will tell you the actual resistance. Continuity will just tell you that there's no electrical breaks in it. Now, voltmeters will only give you continuity up to a certain ohm, maybe 100, maybe 200. So anything outside of that, it won't go beep, even though continuity, resistance-wise, it's in shape. So never check thermistors with continuity. Actually, don't use continuity, period, unless it's like a little thermostat or a little thermal fuse. But if it's like a real, resistor or thermistor, which is basically a resistor who uses temperature for its resistance, always use ohms, all right? That's what I learned in my electronic degree days, and I hope that helped, all right? All right. Lemon Man 77 Able. Yo, we about to be at 12 o'clock, man, and I'm still out here teaching. Holy cow. All right. All right, I can't read no more. All right, let's finish tonight's class. All right, we'll be coming up now on the end, ladies and gentlemen. We're doing component testing. Okay, so again, we learned how to check a defrost heater. We're almost done. We learned how to check a thermistor. We almost done. But we spoke briefly on defrost timer. Okay, there's a way to check that, but if you have any doubt, replace it. It's $5 or it's $6. Get the Frigidaire one, and it works on all of them. All right. And what are we gonna test last? The bimetal. Let's do a bimetal test. Again, based off of the information given, anything over 45, it's not gonna give you resistance. It's not gonna give you continuity. It's gonna read open. Why? Because anything over 45, it opens. Anything under 40, I think 30 or whatever the grid says, it closes. So right now we're gonna take a test, and we should not get no continuity. Listen carefully. So we know that my voltmeter's good, but listen. Nothing on the bimetal. Nothing on the bimetal. Now, I got a little trick to make that bimetal turn cold really fast. And where the hell did I put it? Give me 1 second. I don't have it with me. I had it, but bear with me, guys. Alright, I thought I brought it with me, but basically, if you get a can of keyboard cleaner and you turn it upside down, or you take this and you put it in a cup of cold water and with ice, anything to bring the temperature down on this. But I wish I had my keyboard cleaner, because when you turn the can upside down and you spray it, it gets cold right away. It will close, and then you can run a test on your voltmeter to make sure that those contacts close. And that's how you could check this bimetal. So in theory, you could check the bimetal, you could check the heater, you could check the thermistors using the chart. You could make sure that the board is sending the proper output voltage. So as far as defrost and defrost theory, there's definitely checks that could be done. And there's definitely ways to go about your defrost troubleshooting. But guys, it's already 12 o'clock at night, and this class was supposed to be for the TMM academics. This was a refresher, but I made it public to the world, and I hope y'all enjoyed it. And for videos like this, you know, please go to tmmacademics.com. Me and Rick, we out there every Saturday, and we giving, you know, live training. I'll read a couple questions, and then we'll sign out. All right? Much respect from the West Coast to the East Coast. You already, John Doe, from East to West. Boomerang at you. All right? Daryl Harris. What's good, Daryl? How you? All right, y'all. I think I read everybody. Trinity, Continental, DW. What's good, DW? I think I read everybody. All right, y'all. Well, there y'all have it, man. I hope y'all enjoyed defrost. You know, a little quick defrost, you know, refresher. It's 12 o'clock East Coast time, and then thank y'all for being here. But I'm gonna sign out. I'd like to take this time again to thank my business partner, Rick. I'd like to thank all 29 people in the chat right now. And for those who watch this at a later time, please hit the like, please hit the subscribe, please hit the share. Please go to tmmacademics.com. Please support the channel, buy our merch. And guys, like I said, we're going to take a few weeks off, and we just going to, you know, recuperate and try to work on the storefront. And we'll still drop, you know, videos throughout the week and stuff, but we're not going to go live for a little while. Plus, we want to let y'all miss us a little while. This is a strategical thing we're doing. So with that said, we're going to tap out. We're going to sign out for a little while. And I thank y'all for rocking with us. Hopefully the next time we see y'all, we in our studio, man. And until then, in the meantime, in between time, thank y'all for being with me. I want to thank everybody who participated tonight. Without y'all, this channel is nothing. Love, peace, and harmony. Y'all have a good weekend. Always check 120, wear safety gloves, and practice safety. I'm out.